forgot to record yesterday. So, like, if you're asked for the average value of a function here, then what we're kind of thinking about here is, like, if I integrate this here, I got the area underneath the curve here. And so what we can kind of think about for this is we're sort of trying to make a rectangle there that has the same area as that yellow area right there. So what we did here is we found on this one, like, the integral from -4 to 4 of f of x dx, and we used geometry, and somebody have that, what we get for that? It was like 17.571. Now it's putting crazy rectangles here. There. So that is the, like, yellow area. So if we are taking this rectangle right here and we want it to have that same area, then we already know what the length of that bottom side is, right? What would the length of that bottom side be if this rectangle fits right here? It'd be 8. So what I'm really kind of wanting to know is what's that average height of all the points right there that falls right here. So if this area is 17.571, then I just need to know the height right here. So I just have to divide, right? So if I take that and divide it by 8, so 17.571 divided by 8 gave us 2.196. So I would get 2.196 is that average value. That would be that height of that rectangle that would have the same area under the curve as our graph that we have there. So that is sort of the geometric idea behind average value. The formula that we can use for average value is going to be, if you're looking for the average value of a function over a closed interval from a to b, then your average value is going to be 1 over b minus a times the integral of f of x dx. So let's think about what a graph would look like for this, right? We've got some function that we're looking at from a to b, right? And I don't know what the function looks like, but let's make it, as crazy as we want here. And so if I'm doing this, then the area under the curve from a to b is given by that integral, right? So that would be like this yellow area right here. Right, so this area under the curve is being multiplied by 1 over b minus a right here. What is b minus a, like in terms of that graph? It's that length of that interval. It's the distance from a to b. In the problem we just did, it was 8, right? So basically you're taking that area under the curve and you are dividing it by the length of the interval, right, which is going to give you the height that rectangle would have to be to have that same area, right, in this case. So let's look at some different ways that this gets applied here. So first of all, actually before we look at some different ways that this gets applied, let's look at one that's just like a straight naked problem with no context whatsoever. It just says find the average value of f of x equals 3x squared minus 5x plus 2 on the interval from 1 to 3. Now I am going to graph this on Desmos so that we can relate this to the other things that we have been doing, but this would not be a calculator active problem right here. So you wouldn't be able to just graph it on Desmos. So f of x equals 3x to the second minus 5x plus 2. And then we are looking at this just from 1 to 3. So I'm actually going to 1 is less than x less than 3 here. X should go or equal to there. And so we're looking at this. Let me change my. Let's do x-axis from 0 to 4. So we can see it a little bit better. So we're looking at like this graph right here. And if I screenshot that one, actually, mess it up. Here. Right here is what we're looking at for that graph. So I want to know the average value of that function. It's more or less like the average height of that function, like about where we at. It's definitely going to be somewhere between 0 and 14 because those are the heights that are different endpoints there. It's probably falling around here somewhere. So to find average value, I need to integrate, which would look like this. We'll have the integral from 1 to 3 of 3x squared minus 5x plus 2 dx. And then I would have to divide by the width of the interval, right? And what is our width of our interval here? 2. So we'll usually write this out front like 1/2. So when I do this part, it's giving me that area underneath the curve. This would not be a calculator active question, so you would actually have to integrate. So to integrate, we're going to increase our exponent by 1, divide out front by that number. So like this one would be x to the third. 3 divided by 3 is 1. Then we would get 5/2 x squared plus 2x. And we don't have to put a plus c because we are evaluating this from 1 to 3. And you want to be careful not to forget your 1/2 that was out there. So it will look like this. We'll have 3 cubed minus 5/2 times 3 squared plus 2 times 3 minus 1 cubed minus 5/2 times 1 plus 2 times 1. So 27, this is going to be 9 times 5/2, so that's going to be 45 over 2 plus 6 minus 1 minus 5/2 plus 2. So 27 and 6 is going to give me 33 minus 45. Why do I keep doing that? Minus 45 over 2. I'm going to go ahead and distribute here. We got negative 3 plus 5/2. And so definitely got 33 minus 3 is just 30. And then negative 45/2 plus 5/2 is going to give us negative 40 over 2, which is negative 20. So we get half of 10, which is 5. There. So majority of that is, just arithmetic that you are doing there. And so what that should mean is that if I have a rectangle that has a height of 5 and a width of 2 right here, that area should be the same, the area of that rectangle should be the same as the area underneath this curve right here for that. So, and that looks possible. This feels a little bigger than that right there because it's like tall and skinny, but I guess not. There. Okay, questions on that? All right. So to see an example of this, it's more in being applied. You've got the velocity of a particle traveling along the x-axis is given by v of t equals x square root of x squared plus 1. What is the average velocity of the particle from negative 3 less than or equal to t less than or equal to 3 here? So in this case, we're going to ask for average velocity, and then it's going to ask us for average speed, which is going to be a little bit different here. So let's just start with average velocity then. If they ask you for average velocity, we can just kind of use this formula every time, right? That we are going to do 1 over length of the interval times the integral of that function. So velocity is what you're integrating. What happens here is you integrate velocity and it gives you distance traveled, or distance of displacement here. And so when you integrate velocity, it gives you your displacement, which is in, like, let's call it feet. And then you have to divide it by the length of the interval, which is in seconds, which takes you back to feet per second. There. So if you just remember that if you see something like average velocity, that you're integrating velocity. Or if they ask you for average acceleration, you're integrating acceleration. If they ask you for average position, you're integrating position and dividing by the length of the interval. I don't even know what you get whenever you integrate position, but what happens when you integrate position is it gives you this thing I don't even know how to describe up here. But then you divide it by the time again, and so it takes you back to position. Does that make sense? So, like, what happens when we integrate velocity, it takes us back to position. But by dividing out front by the length of that interval, it takes you back down to velocity again. Exactly, exactly. Yeah, so when I don't even know what you would really call it if you integrate position. But you're dividing it by time again. I guess it'd be like time divided by position, maybe, sort of. I don't even want to go too far with that because I'm not certain. I haven't really ever thought of that before. But when you divide, it takes you back down to what you're working with. So whatever they're asking you for, like, so they're asking us for average velocity, we are going to do 1 over length of the interval, which in this case is 6, and then we multiply that by the integral from negative 3 to 3 of x square root of x squared plus 1 dx. Now, we would be expected to do this without a calculator. So how do I integrate that? That's going to have to be a U substitution. And this is like the kind of U substitution we haven't done in a while, right? Like we did some natural log stuff, but we haven't done this in a while. What's the u going to be? U is going to be x squared plus 1. What is du? 2x dx. Do I have the du that I need? I got the x right here, I got the dx, but I'm missing the 2, so I'm going to put the 2 right here. And if I do that, I got to put the 1/2 out front. You can go ahead and, you can combine these two here if you want. So, that is going to give us, we'll have 1 over 12 times the integral of the square root of u du. What should I do with my limits? Good. So if I do -3, if I do -3 squared plus 1, that is going to give me 9 plus 1, which will be 10. So that bottom limit will become 10. Oh, look what's going to happen here. On the top up here, I'm going to do 3 squared plus 1, and I get 10 right here. So I don't even have to think about how to integrate this, because what am I going to get? I'm going to get 0. So average velocity is 0. And if your velocity is 0, what are you doing? You're not moving, you're just sitting still. So let's look at the graph of this one too to kind of see what's happening here on that graph. So I've got v of t equals v of x equals x square root of x squared plus 1 here. Now, is that from -3 to 3, is my velocity 0? It's only 0 one time, right? So what does this even mean? Like, if my velocity is never only 0 one time, why am I getting 0 for this answer? Okay, so like over here, when I have the velocity is below the x-axis, what does that tell me about the particle if I have a negative velocity? It's going, not necessarily away, but it's going left, right? So I was going to the left, and then I switched and went back to the right. And so all of my positive velocities and my negative velocities end up canceling each other out. So that's why we're getting a average velocity of 0. Now, a lot of times for a lot of things that we're going to deal with, we don't want to really know average velocity. We want to know average speed, right? So like if you drove like backwards, like if you drove if you drove to Winston entirely backwards, and then you drove forwards home, we possibly could say your average velocity was 0 there. But that would, of course, first of all, be very dangerous and difficult to accomplish unless you are a stunt driver. And it would not, matter, right? I'm pretty sure if you're going backwards, the police officer is not, if you are going 70 miles an hour backwards, if you even own a car that will do this, I'm pretty sure the Kia will not go 70 miles an hour in reverse. But if you even own a car that will do this in the first place, and you are driving 70 miles an hour backwards in a 55, I'm pretty sure that you cannot convince the cop that your velocity was really -70, and so it's still less than 55, and that still counts. Pretty sure that's not going to fly. So average speed is what you really want to know for this in a lot of cases. So for average speed, any ideas of what we could do? Okay, Absolute value is good if it's calculator active, because if it is calculator active, then I can do this. I could call it like S of X and do absolute value bars. Where are those at? Oh, here they are. Absolute value bars, X square root of X squared plus 1. And basically it just takes that negative part of the graph and flips it up. And then so if I want to do 1 over 6 integral from -3 to 3 of f, oh, sorry, that was E. 3, what am I doing? -3 to 3 of S of X dx, then it will give me a positive number, which seems much more reasonable for this situation. So if it is calculator active, absolute value bars are excellent to use. If you don't find, like if it's not calculator active, do you guys know how to integrate something in absolute value bars? I doubt it, because I don't think I know how to do it in absolute value bars. So what you're really wanting to look at is, it is helpful if like they've given you a graph, or you could at least graph it to see, but maybe they'll give you a graph in this case, or they may tell you something like this is even or odd function. Like if this is, I don't know, even or odd is kind of hard to do here. If this is an odd function, but it's hard to know that necessarily. But what you're looking at here, this area right here, obviously like canceled out this area over here. So what if we just integrated from 0 to 3 and we doubled it? Would that be okay? Like, would that give us that absolute value area? I believe it would. So you're probably not going to see something like this calculator active where you would get 0 velocity but speed is not 0, unless it is a symmetric graph where you can use this. So if I integrate from 0 to 3 of x square root of x squared plus 1, it's really the same process here. My u is x squared plus 1. My du is 2x dx. I need a 2 right here. I also forgot my dx over here. And then if I put a 2 on the inside, I've got to have a 1/2 on the outside. Right now, I'm not worried about that 1/6 for now. I'm going to wait till I get this whole area, and then I will divide it by 6. If I do this, then I have 1/2 integral of the square root of u du, and I'm going to change my limits here. So I will do 0 squared plus 1, and that will give me 1 for my lower limit. And then I will do 3 squared plus 1, which will give me 10 for my upper limit. And so I can think of this as u to the 1/2. It will be easier to integrate if I think of it that way. So I will increase my exponent by 1, so that'll give me 3/2, and then divide out front by 3/2, which will be 2/3, but I also have that 1/2 that's out there. And I need to evaluate this from 1 to 10. So I will get 1/3 there. If I can go ahead and put like these two things together. And then I need to multiply that by 10 to the 3/2 minus 1 to the 3/2, which will be, this is going to be the square root of 10 to the 3rd, which is 1,000 minus 1. And past here, they'd about have to leave it like this, because you can't do, square root of 1,000 is not a whole number here for that. So this is just integral from 0 to 3. if I want to know the integral from negative 3 to 3 of v of t. I'm using a lot of x's here, and I should have been using t's. Then it would be 2 times this, which would be like 2/3 times square root of 1,000 minus 1. And if I want the average, so this is, if I want the average speed, I would do 1/6 times that integral from negative 3 to 3 of, I'm going to put the absolute value bars here to show that that was in fact, like we were doing speed and not velocity. And that is going to give me, I got to do 1/6 times 2/3, which is going to give me, that'll reduce right there, which will give me 1/9. So I'd have 1/9 square root of 1,000 minus 1. And if they gave this to you calculator inactive, it would have to be some sort of answer choice like this. You wouldn't be able to get a whole number. They might would do the same sort of problem but give you numbers that you could plug in to get a whole number out. If I do 1/9 times the square root of 1,000 minus 1, I get 3.4025, which I think is what we had when we did it with the calculator. Okay, questions? All right. I hope for questions that ask you to do this with the calculator, because it tests your same like knowledge without making this extra complicated on being able to integrate that part. All right. Okay, so that is everything that I have here. Also, just notation alone sometimes throws kids off whenever they start doing these subscripts. So just know that like you're using x for position, v for velocity, you could use a for acceleration, and the subscript is just telling you which point because they're asking you about 2 different points right here. So 2 particles move along the x-axis for 0 to 8. The position of the particle p at time t is given by x sub p of t equals natural log of this stuff, while the velocity of the particle q at time t is given by this. Particle q is at position x equals 5 at time t equals 0. So this is an interesting problem because they have given you position for particle p and they have given you velocity for particle q. So you need to, like, you're not starting with the same thing. A lot of them, like, you got velocity for both particles. That's not the case here. So, so you also need to be really careful and make sure you're using the right equation for the right particle, because some of these questions only ask us about one particle, like A, where it says from 0 to 8, when is the particle moving to the left? Okay, this is not a calculator active question. So if a particle is moving to the left, what do we know should be true about it? Velocity is negative whenever this happens. And of course, if they had asked for the right, the velocity would be positive. So velocity is negative is what we're looking for. Do we have the velocity for particle P?
Yes. No, we have no.
We have it for Q. We do not have it for P. What are we going to have to do to find the velocity? Take the derivative of position, right? So we got x sub P I'm going to call it x sub p prime of t. I'm going to write this, and then I'm going to call that v sub p of t. I think they're going to accept it even if you only write one of those, but this really clearly lets them know you're taking the derivative of position. You know you're getting velocity right here. And so, what do I get when I take the derivative of a natural log? Good. 1 over what's in the natural log, t squared minus 2t plus 10. Anything else go with it? Multiply by the derivative of the inside, because it's going to be a chain rule there. So you got to multiply it by 2t minus 2. And that is in the numerator there. So I would write this as 2t minus 2 over t squared minus 2t plus 10. So, whenever I get this, I need to know where the particle is, the velocity is negative. How am I going to figure out where this is negative? Good. So critical points are places where my derivative either equals 0 or is undefined, right? So that means set the numerator and the denominator equal to 0. So in the numerator, I've got 2t minus 2 equals 0. So that is 2t equals positive 2. So if I divide by 2, I'll get t equals 1. That's a critical point for sure. Now, denominator. T squared minus 2t plus 10 equals 0. Does that factor? What would it be? Five and 2 would give you 3. And they'd have to have opposite signs, which would give you a negative. 4 times 6, you're not adding. You got to multiply to get 10. So the only thing we can multiply to get 10 is 1 and 10, or 2 and 5. And they have to have the same sign, right? Because we got to get a positive 10. Are we going to be able to get a negative 2? We are not. So if we can't factor something, if we can't factor quadratic, how do we solve it? Quadratic formula. So we're going to have to do x equals negative b. So negative 2 becomes positive 2, plus or minus square root b squared, so negative 2 squared, minus 4 times a times c, all over 2a. And so I get 2 plus or minus 4 minus 40 over 2. Now what's 4 minus 40? Negative 36. And if I end up with a negative under the square root, what happens? I got a 6i. Is that a real point? It's imaginary. So you get no critical points. From that. So if we got critical points, we would have to do something with it, but we didn't, so we're going to just skip that part. So we've got only one critical point, it is at t equals 1. So if I do a sign line for this, for v of t, what we're going to find is the denominator is always going to be positive, like 1 squared minus 2 plus 10. Is going to be a positive number. The denominator is just like always positive. So it really does not affect anything. So I'm really just looking at the numerator. 2 times 1, or I don't want to plug in 1. 1 is just going to give me 0. I should plug in a number lower than 1, like 0. And 2 times 0 minus 2 would give me a negative number. And over here, if I plug in a number bigger than 1, like 2, I will get a positive number. right here. And the question only asked me to look from 0 to 8. So where is my particle moving to the left? 0 to 1, right? Because we are looking where the velocity would be negative for that. We're okay there? So we would need to summarize this one and say particle P moves to the left when 0 is less than or equal to t less than 1, because v of t is less than 0 on this interval. Or you can word that a lot of different ways. You say the velocity is negative on that interval or whatnot. Yes?
So, what was the point of solving the velocity stuff?
In this case, there is none because you don't get critical points for it. So it does not, like, if you recognize that, you could skip it. But let's say that we got a positive 6 underneath that, or like, we got a positive number underneath that square root, then we would have to kind of estimate what values those are, and we'd have to put it on our sign line, and we'd have to work this out, which would make it a much harder question to do. All right, go ahead. Good luck, Webb.
So if that fluid and there were critical points nearby, would your velocity be undefined at those points?
No, because the velocity might be undefined at those points where you're getting 0 in the denominator, but in the intervals in between, it would still be positive or negative. So it could still exist. Yes, Lexi. We should, thank you, because there is more than one on this. We should put the P right there. Okay, questions on that? So on that part, you want to remember, if your particle is moving to the left, velocity is negative. That's what you're looking for in this case. All right, let's keep going. All right, so for 0 to 8, we are supposed to find all times which the two particles travel in the same direction. Thankfully, we have already found direction of travel for the first particle, right, for particle P. So we pretty much have to do the same thing for particle Q, right? But do we need to take a derivative for particle Q? Do we have to do anything to it? No. We don't have to do anything to it, which is really what they're wanting you to, like, technically, once you've already answered A, B's not necessarily a calculus problem because you're not integrating or taking the derivative, but what they're wanting you to they're wanting to recognize that you know that, right? That you know you don't have to do anything to it. So you've got V sub Q of T is, what did we have? T squared minus 8T plus 15. 8T plus 15. Okay, so we want to see where this equals 0 for critical points. Thankfully, this one will factor. We're going to get T minus 3 times T minus 8. 5, thank you, equals 0. So we get T equals 3 and T equals 5 for our critical points. And then we're going to do a sign line here from 0 to 8. We need to include 3 and 5. And this one, if you want to make the chart for, you definitely could. The other one I didn't because that denominator was always positive and didn't really make a difference. But here, like if you got t minus 3, t minus 5, and then v sub q of t. So like if we plug in 1 minus 3 give us a negative. Plug in something between 3 and 5, like 4, we would get a positive, and then we get a positive right here as well. For 5, it's going to be negative, negative, positive, which gives us a positive, negative, positive here. So from the last problem, I'm just going to rewrite it down here. For our velocity of p, we got a negative right here and a positive over here. So we want to know when they are traveling in the same direction. So it almost is helpful to like, you may even want to just like put this sign line I just made right here and kind of line it up, because we got that v sub p of t. We got a negative right here from 0 to 1, and then positives everywhere else on that line. So where, so the two particles travel in the same direction. For which time periods are they? 1 to 3 and 5 to 8. And we should put because, I shouldn't put period there, because, what just happened? Because their velocities have the same sign. On those intervals. Okay, questions there? Okay. C. Ask us for acceleration of the particle q at time t equals 2. And then they ask us for speed increasing, decreasing, or neither at time t equals 2. So let's start with acceleration. So the first point of this is finding the acceleration of q at t equals 2. This should be an easy point. What do I have to do to find the acceleration? Derivative of velocity. The velocity they gave us was a very simple velocity, so I'm going to have v sub q prime of t equals a sub q of t, and I'm going to get 2t minus 8. Show that there, even as simple as it is, don't plug the 2 in yet, because there could be a point for it. That might be where the point is at versus plugging it in, and you don't want to miss a point because you plugged something in wrong and messed up there. So, so then you're going to do the acceleration of particle q at 2, which is going to be 2 times 2 minus 8, which is going to give us 4 minus 8, which gives us negative 4. So our acceleration at time t equals 2 is negative 4. there. Now we need to talk about whether speed is increasing, decreasing, or neither. What do we need to know for speed? We've done some of these problems, but it's easy to forget. Okay? We need to know acceleration and velocity, right? Because if I am, the thing that we normally think of is like if acceleration is positive, then I'm speeding up. But that is because we are assuming your direction is also positive, right? So if you have positive velocity, positive acceleration, then you're speeding up. If you have negative acceleration, negative velocity, you're also speeding up. Okay, so you're looking for the same sign in velocity and acceleration. So I would just go ahead and find v sub q of 2. You also could pull it from your sign line here. It's going to be positive. So you could say, pull it from your sign line. I'd just go ahead and find it because it's a pretty easy number to find here. This is going to give you 4 minus 16 plus 15, which is negative 12 plus 15, which will give you 3. And then I would say since a sub q of t, so we're talking about only at the point 2, so it's a good idea to put 2, and v sub q of 2 have opposite signs. The particle is slowing down. When t equals 2. Okay, questions? All right, last part asks for the position of particle Q the first time it changes direction. So, if we're looking for particle Q, what did they give us for particle Q? They gave us velocity. We do not have position. If they asked us for particle P, we just have to plug a number in, which they might do, kind of like they did up here on this velocity right here, where they just gave you the equation. They might do to see if you're paying attention in a problem like this where they've given you two different things. But in this case, we don't know position. How are we going to find position? We got to integrate. But if I integrate from 0 to something right here, my v sub q of t dt, that does not give me position. It gives me the displacement during that time period. So I have to also know where this particle started from. Because maybe it started at 0, 0, and then my displacement is whatever my position is. But it might have started at 7, or it might have started at -2. So we have to know where we're starting from. So I think they tell us up here in the beginning of the problem, it tells us that particle Q is at position x equals 5 at time t equals 0. So the starting place for this particle is 5. Okay. Where am I going to though? What? 0 to what? We want 8 would give us its position at time equals 8, which is like the very end. What time are we supposed to be plugging in right here? It's the time when it changes direction, which Tyler is correct, is 3. Because if you go back up here to your sign line for Q, you had a positive velocity, and then it switched to a negative velocity. So the first time you switch signs on velocity is what they're looking for here. So 3 is what you're plugging in right here. And so we would just use that formula for the equation that they gave us, which was t squared, what was it? Minus 8t plus 15. And we will solve this. So we will get, we got t to the third, we got to multiply by 1/3 up front, minus 4t squared plus 15t, and we are evaluating that from 0 to 3. And then we would need to do 5 plus, we got 1/3 times 3 cubed minus 4 times 3 squared plus 15 times 3 minus 1/3 times 0 cubed minus 4 times 0 squared plus 15 times 0. If it were me, I would stop here. Because this is the problem that you already know, like this is going to be the problem you already know, sometimes it is helpful to, like, you can memorize that the answer to this is 15 or whatever it is, and then you can make sure you get that. So for that sake, which is not going to happen on the real FRQ, let's figure out what this is. This is going to be 1/3 times 27 minus 4 times 9 is 36 plus 45. And then all this stuff over here is just 0. So that's going to be 9 minus 36 plus 45. And we get, let's see, 50, let's see, that's going to give us negative 37, no, negative 27, oh gosh, 45, I'm just going to do this, 54 minus 36, negative 18, no, yeah, negative 18, because it is positive, sorry, it's positive. So 5 plus 18 is going to give us 23. So on a real FRQ, I would stop right here. But tomorrow, if you get this one, it might be helpful to remember it's 23 because you're unlikely to remember it equals all that stuff.